Welcome to this comprehensive guide on bottlenecks. A bottleneck is a performance-limiting component in a system. Think of it like the narrow neck of a bottle restricting water flow. Similarly, one slow component in your computer system can limit the entire system's performance, no matter how powerful other parts are. Bottlenecks work by creating a constraint in your system. When input data arrives faster than a component can process it, that component becomes the limiting factor. The overall system performance is determined by its weakest link. Fixing the bottleneck component directly improves the entire system's performance. A CPU bottleneck occurs when your processor cannot keep up with other components. Signs include your CPU running at 100% usage, while your graphics card sits idle. Gaming stutters despite having a powerful graphics card, and overall system slowness. This typically happens with outdated processors or systems experiencing thermal throttling from overheating. A GPU bottleneck happens when your graphics processing unit cannot match your processor's speed. You'll notice low frame rates despite the CPU being idle, the graphics card running at full capacity, reduced visual quality or texture details, and frame rates that improve when you lower graphics settings. This usually indicates a weaker graphics card paired with a stronger processor. Storage bottlenecks occur when your disk drive is too slow or full, limiting how quickly data can be read or written. Memory bottlenecks happen when you have insufficient RAM, causing your system to swap data to slower disk storage. Both result in significant performance slowdowns, system freezes during heavy use, and excessive wait times for data access. A network bottleneck restricts data transmission between systems due to insufficient bandwidth. Common causes include slow internet connections, outdated network equipment like routers or switches, high packet loss, and network congestion from excessive traffic. These bottlenecks affect download speeds, online gaming performance, and video streaming quality. Software bottlenecks arise from inefficient code, poor algorithms, or bad application configuration. Even with powerful hardware, poorly written software can limit performance. Common issues include inefficient database queries, excessive memory allocations, locking and synchronization overhead in multi-threaded applications, blocking input-output operations, and unoptimized loops. Bottlenecks have multiple causes. Component mismatches occur when hardware specifications don't complement each other. Inadequate resources mean insufficient capacity or bandwidth. Configuration issues stem from poor system design or inefficient settings. Environmental factors include thermal throttling and power constraints. Synchronization problems cause locking and context switching overhead. Finally, imbalanced data distribution and unexpected traffic spikes create bottlenecks. To fix bottlenecks, increase capacity by upgrading hardware, adding redundancy, or scaling resources. Optimize performance by profiling code, improving algorithms, and tuning configurations. Implement load balancing to distribute work evenly and use caching. Finally, monitor continuously using profiling tools and metrics to identify issues before they impact users. Identify bottlenecks through performance monitoring tools and dashboards that track real-time metrics like CPU, memory, and input-output usage. Conduct load testing under realistic conditions and use code profiling tools. Analyze throughput to measure data flow, measure latency to identify delays, and check resource utilization. Popular tools include Grafana, Prometheus, Apache JMeter, and New Relic for monitoring, plus Python cProfile and Java Flight Recorder for code profiling. Prevent bottlenecks by designing scalable architecture from the start. Plan capacity ahead and allocate resources carefully. Test early and often with load tests and stress tests. Implement continuous monitoring with alerts for performance trends. Follow standardized performance guidelines and profile code regularly to remove inefficiencies. Use circuit breakers, rate limiting, and asynchronous patterns. Implement multi-layer caching strategies and optimize database queries and indexes. Remember 5 key points. First, bottlenecks are performance-limiting components that restrict system throughput and can be identified through monitoring and profiling. Second, bottleneck types span both hardware like processors, graphics cards, memory, storage, and network, as well as software issues like code and algorithms. Third, root causes vary from resource mismatches to inadequate capacity to poor design. Fourth, preventing bottlenecks early is much cheaper than fixing them in production. Fifth, follow a continuous cycle of monitor, analyze, optimize, and validate to maintain peak system performance.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.